Hello everyone. Today I'm here with you all with the second last chapter of class 9th maths curriculum, that is statistics. So before starting with the topic, let's understand what statistics is. Statistics is basically a branch of mathematics in which we study about the collection of data, about the presentation of data, about analysis of the data, and from the analysis we are concluding about the data. So all these about the data we are studying under the branch of mathematics that is known as statistics. In this chapter, we'll be learning about collection of data and representation of the data. So what data is? Let's understand it. So data is basically the facts or the figures which are numerical or otherwise collected with a definite purpose are known as your data. It is a plural word. Its singular is your data. So what data could be? It could be rainfall data of any of the city. It could be temperature of any of the city. It could be marks obtained by the students of any of the class. It could be number of family members in any of the colony. So all these is your data. So first of all, we'll be learning about how to collect data. So we'll be learning about your collection of data. So there are two types of data are there. One is your primary data and another is your secondary data. One is primary data, another is secondary data. If the information is collected by the investigator himself or herself, that means suppose we have to collect the information about how many family members are there in any of the colony. And if I am to collect it and I myself is collecting the data, I am to investigate about it, I am to find some inferences about it, and I am myself is collecting the data. In such type of cases, the data is known as your primary data, because the investigator who has to investigate about the data himself or herself is collecting the data. In such type of cases, the data is known as your primary data. Like suppose I am saying that I am to find the average of marks obtained by any of the class students of any of the class, and I am the teacher of that class and I myself is collecting the data. In that case, this data is known as your primary data, because whatsoever the objective of collection of data is, I myself, investigator herself or himself is collecting the data. Such type of data is known as your primary data. And if some data information is already collected by someone else and I am using this data, in such type of cases, the data is known as your secondary data. That means investigator himself or herself is not collecting the data. Already the data is being collected. Suppose I am to work something about your rainfall data of any of the city. So rainfall data is already collected by the meteorological department. So I am simply going over there and whatsoever the records are there, from the records I am taking the data. So data is not collected by me, but still it is collected by someone else. I am using that data. So such type of data is known as your secondary data. So data is of two types. One is your primary, another is secondary. If the investigator herself or himself is collecting the data with whatsoever the objective they are having, the data is known as your primary data. And if data is collected by someone else and someone else or the investigator is using this data not collected by himself, they themselves has not collected the data, they are simply using the data, in such type of cases the data is known as your secondary data. Now let's understand how to present the data. It is your presentation of data. We have collected the data. Now from this data we have to represent this data so that it could be easily understandable. Whatsoever the conclusion we want to take out from this data, we can easily make it. So accordingly we have to present the data. So suppose I am saying that there are 10 students are there and the marks obtained by these 10 students out of 50 are your say 45, 37, say 49, say 36, 35, 43, 42, it is your 34, then your 30, then your 25, 3, 3, 6, 7, 8, 9, 10. So these are the marks obtained by 10 students of any of the class out of 50. Now if I am going to see this data, this is known as your raw data. Simply we have collected the data. So this data is known as your raw data. Now from directly seeing from these data, it is very not easy to understand that what will be the minimum marks, minimum value, what will be the maximum value. So if we will be arranging this data in your either ascending order or your descending order. So it will be easy to make inferences from it, to interpret the data. It will become very easy. So what we will be doing is we will be arranging this either in ascending order or your descending order. So what is the smallest marks over here? It is your 25. So we will be arranging it is 25, then it is your 30, then it is your 34, then it is 35, then 36, then 37. This we have taken, this we have taken, this we have taken. Then it comes your 42, then 43, then 45, and then 49. So how many we have taken? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have taken all the 10 data. Now these marks are arranged in your ascending order. So we can easily say that the minimum marks obtained by any of the student is your 25 and the maximum marks obtained by any of the student is your 49. So the difference between the maximum value and the minimum value is known as your range. Difference between the maximum value of the data and your minimum value of the data is known as your range. So maximum value over here is your 49 and the minimum value over here is your 25. So it will be, range will be your 24 will be the range of these marks obtained or this data. So when it is very less in number, like it was 10 only, so it was very easy to arrange it in ascending order or the descending order. But if the number of marks or the data is very big, it is very large, then how to represent the data? Let's understand it. Just now we have seen that if the data is very large, then it is very difficult to arrange it in ascending order or descending order. So how we can arrange, how we can represent the data when data is your very large? So we can represent the data either in terms of your ungrouped frequency distribution table or we can represent it in your grouped frequency distribution table when your data is very large. So what is your ungrouped frequency distribution table? What is your grouped frequency distribution table? That we will be learning using an example. Now let's see. If 3 coins were tossed 30 times and the number of heads occurring is your, this is the data that shows that how many times your head is occurring when we are tossing 3 coins 30 times. So what we will be doing is we will be representing this data using your ungrouped frequency distribution table. So what we will be taking is we will be making 2 columns. One will show your number of heads, how many times number of heads is coming, and another column will be of your frequency. So what we have done is we have made a table in which we have taken 2 columns. One is your number of heads, another shows your frequency. So how many times your heads is coming? Either it is your 0 times or it is 1 time or it is 2 times or it is your 3 times because 3 coins were tossed. So we will be writing over here 0, 1, 2 and your 3. These are the number of heads. Now, how many times 0 times head is coming? That will be the frequency. That means over here we can see 0 is coming once, 2, 3, 4, 5, 6 times 0 is coming. So frequency of this will be your 6. How many times 1 is coming as the head? That will show the frequency of it. So let's see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 1 is coming. So frequency of it will be your 10. Now let's see how many times 2 times head is coming. That will be your 1, 2, 3, 4, 5, 6, 7, 8, 9. So frequency will be your 9. That means 9 times head is coming 2 times. 2 times head is coming. That is, its frequency is your 9. And what is the frequency for 3? 1, 2, then your 3, 4, 5. So its frequency is your 5. So some of the frequency should be your 30 because coins are tossed 30 times. That's the reason some of the frequency should be your 30. Let's check it out. Total 10 plus 6 is your 16. 16 plus 9 will be your 25. 25 plus 5 is your 30. So this is how we can represent this data in your ungrouped frequency distribution table. Like over here, there is no grouping. We have not taken 0 to 1 or 1 to 2 or like that. Individually, we have taken 0, 1, 2 and 3. So that's the reason we have not made any groups of it. That's the reason it is known as your ungrouped frequency distribution table. Now, what is your grouped frequency distribution table? So again, grouped frequency distribution table is of two types. One is your non-overlapping type, another is your overlapping type. So what all these are, we'll be understanding right now. So the second question is distance in kilometer of 40 engineers from their residence to their place of work. So over here for 40 engineers, distance between their residence to their workplace is given to us. We have to represent this data in your grouped frequency distribution table. So how we will be representing it? So we can see over here the minimum distance is almost your 2 kilometer, and your maximum distance is going somewhere your it is a 32 kilometers. So what we'll be doing is, instead of writing each number individually, that means 2 kilometer, how many engineers are there who are residing from whose distance of their residence to the workplace is your 2 kilometer, how many are 3 kilometers far residing, how many are 4 or 5, like that. Instead of doing that, we will be making groups of it. So what we will be doing is, we'll be taking in the ones, we will be taking your 1 to 5 kilometer, then your 6 to 10 kilometer, then your 11 to 15 kilometer, then your 16 to 20 kilometer, 21 to 25 kilometer, 26 to 30 kilometer, then your 31 to 35 kilometer. This is the class interval we have taken. This is what it is showing. It is distance of the residence from the workplace. This is it is showing. Now, because we have taken it in groups from 1 kilometer to 5 kilometer, that's the reason these type of frequency distribution table is known as your grouped frequency distribution table, because we have taken groups of it, and these are known as your class interval. 1 to 5, 6 to 10, all these are known as your class interval. These are your class interval, and the size of these class intervals is known as your class size or class width. We say it as either class size or class width. This is your size of your class. Now the lower value of this class interval, this is your lower class limit. Over here for the class interval 1 to 5, 1 is your lower class limit and 5 is your upper class limit. Lower class limit and upper class limit. If we are going to consider the class interval 16 to 20, then 16 will be the lower class limit and 20 will be the upper class limit. So this is how we have made the groups of these distances. Now what we will be doing is, we will be making a table. Then how many engineers are coming whose distance between their residence to workplace comes under the category of 1 to 5 kilometer. For that we will be making a tally marking, and then we will be taking the frequency. Now we'll be completing this table. First of all, we have made your columns and rows we have made like this. Now see, your 5 kilometer, this will come under this column, this class interval. 5 will come under this class interval, because here 1 to 5, all the distances which are from 1 to 5 will come under this class interval. The ones whose distance will be 6 to 10 will come under this class interval. The distances from 11 to 15 will come under this class interval. So well, let's see, 5 will come over here, 1 to 5, 5 will come over here, then 19 will be coming here, 16 to 20, in this 19 will be coming, then it is your 7 will come here, 6 to 10, then it is your 12 will come from here, 11 to 15, then it is your 3 will come here, 10 will come in the category of 6 to 10, then it is your 9, it will come again here, then 14 will come here, then it is your 10 will come here, 12 will come here, 7 will come in this. Already 4 are there, so for 5 we'll make a cross line, then it is your 2 will come here, then 20 will come here, 17 will again come here, 8 will be here, then your 9 will again here, 25 will be here, 18 will come here, then your 3 will be here, 6 will be here, then 11 2 times 11 is coming, so 11 will come here one time and one more time, so 5 will be like this. This is your 11, then again 5 will be here, so then 15 will be here, 13 will be again here, 32 will lie here, 12 will come here, then 15 will come here, 7 will be here, 17 will come under this category, so it will be fifth number it was, so fifth we have crossed it. Then it is your 15 will be here, then 7 will be here, 12, 16, then 18, then 6, then 31, then 2, then 3, and then 12. 12 will be here. Now we will be making the frequency. It is for 5 and 2, 7. Frequency for 1 to 5 kilometer will be 7. So it shows that there are 7 engineers are there whose distance from their residence to workplace is your from 1 to 5 kilometers. Then it is your 5, 5, 10 and 1, 11. Then it is your 12. Then it is your 7. It is 1. Here it is 0. Here it is 2. So again total should be equivalent to your 40, because 40 engineers we have taken 40 engineers, so the sum of the frequency should be your 40. So 11 plus 7 is your 18, 18 plus 12 will be your 30, 37, 38 and 2 40, so its frequency is 40. So this is how we can represent this data into your grouped frequency distribution table. Over here we can see that the upper limit of this class interval 1 to 5 and the lower limit of the next class interval, that is your 6, they are not same. Over here it is your 5, upper limit of this class interval is 5 and the lower limit of this class interval is your 6. They are not the same. That's the reason this type of class interval is your non-overlapping class interval, because the upper limit of one class interval is not same as the lower limit of your next class interval. That's the reason these type of class intervals are known as your non-overlapping class intervals. Now, if we have to convert this into your overlapping type of class interval, then what we'll be doing and why it is required even. Suppose I am going to say that there is any of the engineer is there whose distance from their residence to workplace is say 5.5 kilometer, or say it is distance is your 15.5 kilometer. So where we are going to keep these numbers 5.5 kilometer and 15.5 kilometer. Over here we can see the first class interval is from 1 to 5. So 5.5 cannot be included over here. The second class interval is from 6 to 10. So again 5.5 cannot be included over here also. So where we are going to keep your 5.5. Similarly 15.5. So 15.5 over here we can see this class interval is from 11 to 15 and this class interval is from 16 to 20. So in both the class intervals we cannot keep your 15.5. So in these type of questions, where to keep these numbers? So for overcoming this type of problem, what we do is we just convert this your non-overlapping type of class interval into overlapping type of class interval. So how we can convert it? First of all, we will see the upper class limit of this class interval and the lower class limit of the next class interval. Over here it is 5 and it is your 6. So what is the difference between 2? 6 minus 5 is your 1. So we will be dividing this 1 by 2. That will be your 0.5. So in every class interval from the lower class limit, we will be subtracting 0.5 and in the upper class limit, we will be adding 0.5. So this class interval will become 1 minus 0.5 will be your 0.5 and 5 plus 0.5 will be your 5.5. This is your distance. Or you can say class interval it is distances. Then next is your 6 to 10. From here it will be subtracting 0.5 from 6. It will become your 5.5. And if we will be adding 0.5 in 10, it will become your 10.5. The next is 11 to 15. If we will be subtracting 0.5 in 11, we will be getting 10.5. And if we will be adding 0.5 in 15, we will be getting 15.5. Similarly, this class interval will be from 16. If we will be subtracting 0.5, it will be 15.5. And the next will be 20 plus 0.5 will be your 20.5. So over here we can see that the upper limit of this class interval is your 5.5 and the lower limit of the next class interval is even your 5.5. So because it is same, that's the reason these type of class intervals is known as your overlapping type of class interval, and generally we represent the data in your overlapping type of class interval only, because whenever these type of problems will arise, we have to convert this non-overlapping type of class interval into your overlapping type of class interval. That's the reason in most of the cases we just prepare your grouped frequency distribution table in terms of your overlapping type of class interval only. Now, where we'll be keeping this 5.5? In which class interval we'll be keeping? Because 5.5 is coming here also and 5.5 is coming here also. So for convention, we are keeping this 5.5 in the class interval where this is your lower class limit. So 5.5 will be the part of your this class interval 5.5 to 10.5. In this class interval, your 5.5 will be included. Similarly, in 15.5 will be part of your this class interval, because in this class interval your lower limit is your 15.5. It will not be the part of your 10.5 to 15.5 class interval, because we'll be taking it in your 15.5 to 20.5 class interval. So whenever these type of numbers are coming, then always they will be the part of class interval which are having this number as your lower class limit. That will be the class interval in which we will be including these values. So hope it is clear that how we can convert this data, how we can represent this data in your ungrouped frequency distribution table, and how we can represent data in your grouped frequency distribution table. When your data is very big, it is better to convert it into, to represent it into your grouped frequency distribution table. First of all, we'll be making the grouping. Grouping we can make as per our convenience. Class size could be vary as per our convenience. We can make the big class size also. We can make the small class size also. It all depends upon us. There is no strict rule behind it. If it is mentioned that this should be the class interval, then we have to take that only. But if it is not mentioned, then we can take as per our convenience only. These are the questions from the exercise only. So this is how we will be representing data. If your number of data is like this, so we can represent it into form of your ungrouped frequency distribution table. And if frequency or data is like this, in that case it's better to convert it into your grouped frequency distribution table, because it varies from 2 to 32. So it's very difficult if you'll be writing 2, 3, 4, 5, 6 up to your 32. So that's the reason it's better to go for your grouped frequency distribution table. Over here your hats were only 0, 1, 2 and 3. So that's the reason it was easy to represent like this. It's not required to convert it into grouped frequency distribution table. But if your data varies from 2 say to your 32, 35, all these numbers, so it's better to go for your grouped frequency distribution table. So this is how we can represent the data in your tabular form. Now we'll be seeing how we can represent data in your graphical form. Just now we have seen that how to represent data in the tabular form. Now we will be seeing how we can represent data graphically. So there are three methods of representing data graphically. One is your through bar graph, second is histogram, and third is your frequency polygon. So now let's understand how we can represent data using your bar graph. So what bar graph is? In the bar graph, we are representing data using making your bars. Bars will be of equal width. The width of the bars which we will be taking will be equal, and the spacing between the bars even will be equal. We will be making bars on the x-axis which shows the variable, and on the y-axis we will be taking the value of the variable. The height of the bars represent the value of the variable. So let's understand how we can plot any of the data, how we can represent data using your bar graphs. Let's take an example from your question exercise 14.3. That is your question number 3 we are taking. Given below are the seats won by different political parties in the polling outcome of state assembly elections. Political parties are your A, B, C, D, E, F, and seats won are your 75, 55, 37, 29, 10 and 37. So draw a bar graph to represent the polling results. This we have to represent using your bar graph. So what we will be doing is, we will be making x and y axis. This is your x axis, this is the origin O, this is your y axis. On the x axis, we will be taking the variable, that is your political parties. This is the variable political party. And on the y axis, we will be taking values of the variable, that is seats won. Seats 1, it will be taking on the y-axis. Now the parties are your A, B, C, D, E, F. we'll be representing these parties using your bars of equal width, and the spacing between the bars will even be equal. Scale we can take as per our convenience. So A is your minimum value of the seats 1 is your 10, and maximum it goes till your 75. So we'll be starting from here 0. It is we are taking 10, then 20, 30, 40, 50, 60, 70, 80. Like this we'll be representing the values on the y-axis. Now for A party it is your 75. That means it will lie somewhere here. 75 will be somewhere here. So from unit distance we'll be making a bar. We'll be making a bar like this. This is suppose unit distance. So this will be the width of the bar like this. For every party, your width of the bar will be same and the spacing between the two bars will even be same. This is your party A. 75 its value was. Now for the B, it is your 55. Now from here, at equal distance, we'll be taking party B and its value is your 55. So it will be somewhere here. Like this, we'll be making the bars of uniform width. This is for party B. We will be making it using ruler, so it will be straight lines. For C, it is your 37. So for C, it is your 37, somewhere here. C, width of the bars will be same and spacing between the bars will even be same. For D, it is 29. So for D, it is 29 like this. It is D, 29. Then it is E10. For E, it will be 10 like this. For F, it is your 37. So 37 like this. So what we need to take care of is the width of the bars should be equal and the spacing between the bars should even be equal. On the x-axis, we'll be taking the variable. Over here, political party is the variable. And on the y-axis, we'll be taking the value of the variable. Over here, seats 1 is your value of the variable. The height of the bars shows the value of the variable. The more the value of the variable will be, the more will be the length or the height of the bars. This is how we can represent any of the data using your bar graphs. Now let's understand another method of representing data graphically, that is your histogram. So what is histogram and when we are using this method of representing data graphically? Let's understand it. So histograms are basically used when your class intervals are continuous. For the continuous class intervals, the method which we are using for representing data graphically is your histogram. So in the histogram, we are making rectangular bars and the width of the rectangular bar shows the class size and the length of the rectangular bar shows the frequency of the class interval. Now what we are doing is, because it is being used for continuous class interval, that's the reason it is a continuous figure is there. A solid figure we are getting. There is no gap between the rectangular bars. So it is a solid figure and this is known as your histogram. As we were saying in the case of your bar graphs, that the width of the bar does not make much difference. It is not as significant. But in the case of histogram, it is very important to take care of the width of the rectangular bars even, because area of the rectangle is your directly proportional to the frequency. So how we can represent data using your histogram? Let's understand using an example. Let's see question number 4 of your exercise 14.3. The length of 40 leaves of a plant are measured correct to 1 millimeter and the obtained data is represented in the following table. Length is given in millimeter and number of leaves is even given. It is 118 to 126 and next is your 127 to 135. Just now we said that we are using histogram for continuous class interval. Over here we can see it is not continuous. So first of all we will convert it into continuous class interval. So first of all we are making the table length in millimeter and number of leaves. For converting it into continuous, just now we have seen that we will be seeing the upper class limit of the first class interval and the lower class limit of the next class interval. The difference between two is your 127 minus 126, that is your 1, and 1 divided by 2 is your 0.5. So we will be subtracting 0.5 from the lower class limit, and we will be adding 0.5 in the upper class limit for converting it into continuous class size. So what we will be doing is 118 minus 0.5 will be 117.5 to 126.5. In the next class interval, it will be 126.5 to 135.5. The next is 135.5 to 144.5. Then 144.5 to 153.5. The next is 153.5 to 162.5, 162.5 to 171.5. Then it is 171.5 to 180.5. So this is your class interval with continuous, which is continuous because where the upper limit of the first class interval is ending, over there is your second class interval, lower limit is starting. The upper limit of this class interval is 126.5 and the lower limit of this class interval is 126.5 because it is same. So it is your continuous class interval. So we have converted it into continuous class interval because histograms are used for continuous class intervals only. Now the frequencies, number of leaves will be seen. It is your 3, 5, 9, 12, 5, 4 and 2. Now we will be representing this on the histogram. How we will be plotting it? Again, we will be making the x and y axis. This is your O, this is your x, this is your y. Over here, we will be taking length in millimeter. Again, it is not starting from 0, so we will be making a break using kink. We will be making a kink over here because it is not starting from 0. So it is your 117.5 to 126.5. So this class size will be represented by the width of your rectangular bar. And over here, number of leaves will be coming on the y-axis. We will be representing number of leaves. And the maximum number of leaf is going to your till 12. So we will be taking from 0 to 2, then 4, then 6, then 8, then 10, and then 12. Up to 14 we are taking. Now first is your 117.5, starting from 117.5 like this. Its frequency is, number of leaves is your 3. So from here till 3. This is 3. This is 3. And it is ending at your 126.5. 126.5. This is your class size and this is the width of your rectangular bar. Now 126.5 to 135.5, number of leaves is your 5. So from here 5, number of leaves is 5. So it is 126.5 to 135.5. Now for from 135.5 to 144.5, it is 9. Number of leaves is your 9. So we'll be going here. Straight lines we'll be making using ruler. This will end at 144.5. Now from 144.5 to 153.5, it is 12. So from here, we'll be making till 12. It is your 153.5. Then it is 153.5 to 162.5, it is 5. It is 5 here. The width will be same. It will be 162.5 till 162.5. From 162.5 to 171.5, it is 4. It is 4. This is a 171.5. And from 171.5 to 180.5, it is 2. So from here, it is 2 till 180.5. So it is your continuous class intervals are there. So there is no gap between the rectangular bars. The width of the rectangular bars shows your class size and the height of or length of the rectangular bar shows your number of leaves over here. That is your frequency of the bars. Frequency of your class interval is shown by your length of these bars. This is how we can represent data using your histogram. Just now we discussed that in the histogram, the area of the rectangular bars is directly proportional to its frequency. So if the class size is equal for all the class intervals, then there is no problem. We can make the histogram as just now we had discussed. But if the class size is different, in that case we have to change the length of the rectangular bars proportionately. So how we will be doing it? Let's understand. Let's take a question number 8 of the exercise. A random survey of the number of children of various age groups playing in a park was found as follows. Age in years is given to you as 1 to 2, 2 to 3. Just I'm making the table. Question number 8 it is. Age in years and number of children. Number of children. It is 1 to 2, 2 to 3, 3 to 5, 5 to 7, 7 to 10, 10 to 15, 15 to 17. This is the age and number of children is given to us as, first of all, I'm making the table like this. Number of children are given to us as 5, 3, 6, 12, 9, 10 and 4. Now over here what we can see is, over here class size is your 1, from 1 to 2 it is 1, 2 to 3 it is again 1, 3 to 5 it is your 2, 5 to 7 it is 2, 7 to 10 it is your 3, 10 to 15 it is 5, 15 to 17 it is 2. So class size is different in most of the cases. So what we will be doing is, we will be changing this frequency accordingly, proportionately we will be changing it. So what we will be doing is, we will be considering the lowest class size. Over here lowest class size is your 1. So according to your 1 class size, we will be changing rest all the number of children, even frequency even will be changing accordingly. So over here we'll be making one more column which we are going to consider, that will show the length of the bar, length of rectangular bar it will be showing. So for 1 it is 5, so we'll be taking this as it is, because 1 multiplied by 1 will be taking 5 only, its length will be till 5 only. For this class size, it is even 1, 2 to 3 it is again 1, so it will be 3 divided by 1 multiplied by 1, that is your 3 only. Now for this 3 to 5 class size is your 2, so it will be length of the rectangular bar will be 6 divided by 2, because class size over here is 2, so 6 divided by 2 multiplied by 1, that will be length of your rectangular bar will be 3. It won't be 6, it will be 3, because area of the rectangular bar is proportional to its frequency. That's the reason we'll be taking it as 3, not 6. Then here 5 to 7, again your class size is your 2, so it will be 12 divided by 2 multiplied by 1, that is your 6. So length of rectangular bar will be 6 over here for this case. From 7 to 10 it is your 3, class size here is 3, so length of the rectangular bar will be 9 divided by 3 multiplied by 1, that is your 3. Length of the rectangular bar will be 3, it won't be 9, it will be 3. Then 10 to 15 it is 10, so 10 to 15 your class size is 5, so the length of the rectangular bar will be 10 divided by 5 multiplied by 1, because your smallest class size is 1, so we have taken 1 as your base, so it will be your 2. Length of a rectangular bar will be your 2. Then 15 to 17 your class size is 2 over here, so it will be 4 divided by 2 multiplied by 1, that is your 2. So this will be the length of the rectangular bar. Instead of these rectangular bars length, we will be considering these as your rectangular bars, because over here class size is different for different class intervals. Class size is different, and we know that the area of the rectangular bar is proportional to your frequencies. That's the reason we will change it proportionately, and this will be the frequency which we will be considering. This will be the length of the rectangular bars which we will be considering. So this is how we will be changing it if your class width, class size is not equal. So we will change it accordingly. Now let's understand one more method of representation of the data graphically. That is your frequency polygon. So how we can make the frequency polygon? Let's understand it. So for making the frequency polygon, what we could do is we have to make the histogram first. First of all, for the given data, we have made the histogram. We know that the histogram is made for your continuous class interval. So for the continuous class interval, we have made the histogram of your same width. The rectangular bars are of same width, which shows your class size, and the length of your rectangular bar shows your frequency. So we have made the histogram. Now what we will be doing is, for every rectangular bar, we will be taking the middlemost point of the uppermost rectangular part. This is the upper rectangular bar. This we have taken the middlemost point of this rectangular bar. This point. Then we have taken, for this rectangular bar, we have taken the middlemost point. For this rectangular bar, we have taken the middlemost point. For each and every rectangular bars, we will be taking the middlemost point. We have taken all these points. We have taken. Now we will be joining these points by your line segments. From here to here, I'll be joining every adjacent rectangular bars points. I'll be joining. Now this point will be joined with the adjacent rectangular bars midpoint. Now for this, midpoint will be joined by your adjacent rectangular bars midpoint. Then this point will be joined by this. This will be joined by this. Now what we will be assuming is that there is one more class interval is there with frequency 0. Over here it is a 30.5. So somewhere here it will be 25.5 also. And the middlemost point from this two is this is the point, and it is having a 0 frequency. So I'll be joining this point with this point. These points I'll be joining. Similarly, over here also I'll be considering that there is any class interval is there with 0 frequency. It is your 60.5. So next will be your 65.5. So middle portion of these 60.5 and 60.5 midpoint I'll be taking, and with the 0 frequency, and I'll be joining it. This is how this dotted line shows your frequency polygon. Suppose this is your point A, this is your point B, this is your point C, D, E, F, G and H. So this A, B, C, D, E, F, G, H shows your frequency polygon. And we can see over here that the area of the histogram is equivalent to the area of your frequency polygon. How we can say that? See, if we are going to make this figure precisely using your rulers, properly we will be making. So we can say that this portion, this triangle and this triangle, they are your congruent triangles. And we know that if the triangles are congruent, or if there are any figures which are congruent, then their areas are also congruent. So area of this triangle will be equivalent to area of this triangle. So we are in the frequency polygon, we are excluding this part, but we are including this part. So the area of this will be compensating your area of this. Similarly, area of this rectangular part will be equivalent to area of this rectangular part. Area of this rectangular part will be equivalent to area of this rectangular part. Area of this rectangular part will be equivalent to area of this rectangular part, because they are your congruent triangles. So we can say that the area of your histogram will be equivalent to your area of your frequency polygon. So using your histogram, we can make the frequency polygon, and without histogram, without making histogram also, we can make your frequency polygon. Suppose this is the data given to us. Heights is given and number of students is given. So what we will be doing is, we will be, first of all, we will be finding your class mark. Class mark we will be finding, that is your upper class limit plus lower class limit divided by 2 will give you your class mark. So first of all, for every class interval, we will be finding your class mark. So over here, first one more column we'll be making. For every class interval, we'll be making the class mark. Over here, 140 plus 150 divided by 2 will be your 145. This is your class mark. 150 plus 160 divided by 2 will be 155. It will be 165, it will be 175, and it will be your 185. So instead of taking these as your rectangular bars, we will be working on this class mark. We will be taking these class marks and these as your frequency, and we'll be making the frequency polygon like this. This is your x-axis, this is your y-axis. Over here, we'll be taking your height, and over here we'll be taking your number of students. See over here, your height does not start from 0. So again, we'll be making a kink over here. Now, it is your 145. At 145, frequency is your 5. So we'll be taking here 145. This is your 145. And the frequency over here, it is your 2. It is 4. It is 6, 8, 10, 12, 14, like this I have taken. So at 145 it is your 5. So 145 it is your 5. I have made the dot. At 155 it is 10. So 145, after that it will be 150. After 155 it is. After that it is your 165. After that it is your 175. At equal distances will be taking, it is your 185. Right? So 145 your frequency is 5. 155 it is your 10. At 155 it will be your 10. Then at 165 it is your 12. 165 it is your 12. 175 it is 3. 175 it is 3. Then 185 it is 2. 185 it is your 2. Now again we will be taking one more class preceding to this class, where we will be taking frequency as 0. So 145 here, so we will be taking it as 135. 135 and frequency is 0. And after 185 it will be your 195, where frequency is 0. So we will be joining all these points from 0 to here, then from here to here, then here, like this. So I will be joining it like this, and with a 0 frequency. This is your frequency polygon. So using histogram, even we can make the frequency polygon, and if histogram is not there, directly even without making histogram also we can make the frequency polygon. In that case we have to find the class mark once. Class mark we can get it by upper class limit plus lower class limit divided by 2. For this class interval, 140 is the lower class limit, 150 is the upper class limit. So if we will be adding 140 plus 150 by 2. So it will be 290 by 2, that is 145. Similarly, for every class interval, we will be finding your class mark, and with respect to the class mark, we will be taking the frequency. Again, we will be taking one frequency preceding and one succeeding with the 0 frequencies also, and then we will be joining all this, which will give you your frequency polygon. It is very much useful for comparing any of the two things of same nature. Now let's understand measures of central tendency. So there are three methods of finding measures of central tendency. That is your mean. First is mean. Second is median. And third is mode. Now we will understand that what is mean, what is median, what is mode, and how to find its values. So first of all, starting with your mean. Mean is basically your average. Average, and the formula for finding mean is represented by your x bar, and it is sum of all the observations, upon total number of observation. This is the formula for finding mean of any given data. Suppose this is the data of any 6 students. These are the marks of any 6 students out of 10. So what will be the mean of this data? So what we will be doing is, we will be finding sum of all these observation divided by total number of observation. So mean, that is your x bar, will be sum of all this, that is 5 plus 7 plus 3 plus 6 plus 4 plus 5. So how many numbers are there? 1, 2, 3, 4, 5, 6. Total number of observations are 6. So divided it by 6. So it will be 10, 20, 30. 30 divided by 6, or we can say mean will be your 5. So mean is given by your x bar, could be written as summation. This is the sign for summation, that is addition. Summation of your xi over n, where I varies from 1 to n. That means number of observation. If it is your n, then I varies from 1 to n. This is the formula for finding mean. X bar is equals to summation of xi, where I varies from 1 to n divided by n, will give you the formula for finding mean. Now, if it is not in this form, if it is like this, like these are the marks and these are the number of students, that means frequency is there, and these are the marks of any of the, say how many students are there, 3 to 5, 6, 7, 10 students are there, and these are the marks of 10 students out of 10. So what will be the mean? In these type of cases, first of all, we are finding Fi, Xi. These marks are your Xi. Number of students, that is frequency, is your Fi. First of all, we will be multiplying these two. So 3 multiplied by 1 will be your 3. 5 multiplied by 2 will be your 10. 10 multiplied by 3 will be 13. 8 multiplied by 2 will be 16. 9 multiplied by 2 will be 18. So we'll be taking total. One more row will be making. So it will be your 8, 14, 17, 7 carry over 1, 4, 5, 6, 77. And the sum of all the frequencies is your 10. Because total 10 students are there. So 2 to 4, 7, 9 and 10. So sum of frequency is your 10. And this is the summation of your Fi, Xi. So in these type of cases, your mean is given by summation of Fi, Xi, where I varies from 1 to n, divided by summation of Fi, where I varies from 1 to n. So this is your multiplication. First of all, we'll be multiplying your Fi and Xi, and then we will be adding for 1 to n. Here your I varies from 1 to n, divided by summation of Fi. Summation of Fi means sum of addition of all the frequencies, again where I varies from 1 to n. This is the formula for finding mean. So mean is basically your sum of all the observation upon total number of observation, which is basically average even. So this is one of the method of finding your central tendency. Now we'll be learning what is median and what is mode. Now let's understand what is median and what is mode. So first we are taking the case of your median. What median is? Median is the value of the observation which is dividing it into two equal halves. Means dividing into exactly two equal parts. Suppose I am going to say that there are say 7 observations are there. Any 7 students are there. We are considering the marks of any 7 students. Like suppose the marks obtained out of 10 is your 7, 5, 9, 8, 3, 3 to 5, then your 6 and your 8. These are the 7 students and marks obtained by these 7 students out of 10. Now, first of all, what we will be doing is for finding median, we will be arranging these either in your ascending order or your descending order. So first of all, we are arranging this number, these data in your ascending order. So it will be your 3, 5, you have taken this, then your 6, then your 7, then your 8, then 8 and then 9. These are the 7 data we have taken. Now here the number of observation is 7. That is your odd number of observation. So if number of observations that is n is odd, in that case n plus 1 by 2th observation will be the answer, will be the median. N plus 1 by 2th observation will be the median. Over here your n is 7, n is odd, which is 7. So 7 n plus 1 by 2th observation. That means 7 plus 1 by 2th, means 8 by 2th, or we can say 4th observation will be the median. 4th observation. So 1, 2, 3, 4th. 4th observation will be the median. So median will be your 7. So if the number of observations is odd, in that case n plus 1 by 2th observation will be the median. Here first what we are doing is, first of all we are arranging all the data in your ascending order. Once we have arranged it in ascending order, we will check that how many numbers of observations are there. If the number of observations is odd, then n plus 1 by 2th observation will be the median. See over here, this is dividing over here. In the left side, there are 3 numbers are there, 3 observations are there. In the right side even, there 3 observations are there. That means this is the middlemost observation, dividing into exactly 2 parts. Now, if the number of observations, that is n, is even, in that case, n upon 2th and n upon 2 plus 1th observation, average will be finding. Average of n upon 2th observation and n upon 2 plus 1th observation we will be finding, and that will be the median. Now suppose instead of this we are taking another data. Say the numbers are your 4, 7, 8 and say 6. These are the four numbers are there, four observations are there. We have to find the median of this observation. Over here, first of all, what we will be doing is we will be arranging these observation in ascending order. So first of all, arranging in ascending order, so it will be 4, 6, 7, 8. This is how we have arranged this in ascending order. Now what we will be doing is, over here we can see that n is 1, 2, 3, 4. Number of observation is 4. So value of n is your 4. So we'll be finding n upon 2th observation. So 4 upon 2th observation, that means second observation. 4 upon 2 means 2, second observation, and 4 upon 2 plus 1. This is 4 upon 2 is 2, 2 plus 1 means third observation. So we have to find the average of second and third observation. From here we can see second observation, first, second observation is 6 and third observation is 7. So we have to find the average of second and third observation. That will be your 6 plus 7 by 2. Average means adding these two divided by number of observation, that is your 2. Sum of observation divided by number of observation. 6 plus 7 is 13 by 2, or we can say 6.5 will be the median. Over here the 6.5 is not any of the observation, but still your median is coming as 6.5. So it is not compulsory that median will be your one of the observation only. So it could be, it is even possible that whatever the median is coming, it is not your observation. So if your number of observations is even, in that case the average of n upon 2th observation and n upon 2 plus 1th observation will give you your median. Two cases will be there. Either your number of observation will be odd or your number of observations will be even. If number of observation is odd, then n plus 1 by 2th observation will be the median. And if number of observation is even, in that case average of n upon 2th observation and n upon 2 plus 1th observation will give us the median. This is how we can find it out. But important is, first of all, we have to arrange the data in your ascending order. This is to be done. Now let's see what mode is. Most frequently occurring observation is your mode. The observation which is occurring most frequently is your mode. Suppose there are 10 students and out of 10, the marks obtained by these 10 students are your 7, 8, 8, 5, 6, 8, 9, 10, 4, 5, 6, 7, 8, then your 6 and then your 7. These are the marks obtained by 10 students out of 10. Right? So we can see over here that maximum students, there are 3 students who have secured your 8 marks. There are 2 students who have secured 7. There are 2 students who have secured 6. But there are 3 students who have secured 8. So maximum number of students have secured your 8, or we can say maximum most frequently occurring observation is your 8. So mode will be your 8. Mode will be 8. So most frequently occurring observation. Most frequently occurring observation is your mode. It helps us in selection of the, like, which size of the shirt should be made more. It helps us in industries, like which size of the shoes is mostly sold. So in all these type of cases, it is being used to decide that which size of the shirt, which size of the shoes should be made more frequently, or mostly they should be made because they are mostly sold. So for all these type of cases, your mode is being used. Now, if there are any extreme conditions are there, any extreme observations are there, like suppose most of the students had secured, say like this, and any of the student has secured, say 2, and say one more student has secured, say again 1. So if there are extreme conditions are there, so these are the numbers, these are the observations which affect your mean. Mean is affected by extreme numbers. If very less or very high number is there, any high observation is there, then it is affecting the value of the mean. But your median and mode is not affected by your extreme values. So whensoever any extreme values of the observations are there, then mean is not the suitable way of finding your central tendency. In that case, your mode or the median are the best suitably used. But if there is no such extreme conditions are there, extreme observations are there, then mean is even a very good way of finding your central tendency. So now let's understand some of the questions from your exercise. Exercise 14.4. Question number 1. The following number of goals were scored by a team in a series of 10 matches. The goals were 2, 3, 4, 5, 0, 1, 3, 3, 4, 3. These are the number of goals scored by a team in a series of 10 matches. Find the mean, median and mode. Now see over here. First of all, we are finding mean. Mean is your sum of all the observations. Sum of all the observations divided by total number of observations. So first of all, we will be adding all these observations. So 2 plus 3 plus 4 plus 5 plus 0 I am not writing, plus 1 plus 3 plus 3 plus 4 plus 3. But in the number of observation it will even be counted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is the number of observations. So we will be dividing it by 10. Now we will be adding it. 3 to 5, 5, 5, 10, 14, 15, 18, 21, 25, 26, 28. 28 by 10 we can say 2.8 will be the mean. Now for finding median we have to arrange this in ascending order. So we will be arranging it. First of all 0 we are taking. Then it is 1 is coming once, then 2, then 3 is coming 1, 2, 3, 4 times. 1, 2, 3, 4 times, then 4, and then 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have taken all the 10 observations. Now the median will be, because it is an odd number, 10 is an odd number, so n upon 2th observation. N upon 2th means 10 upon 2th 5th observation, and n upon 2 plus 1, that is your 6th observation. Average of 5th and 6th observation will be taking. So 1, 2, 3, 4, 5 and 6. So 5th observation is 3, 6th observation is even 3. So median will be average of these two, that is 3 plus 3 by 2, that is 6 by 2. So median will be your 3. Now mode. Mode is your most frequently occurring observation. So we can see over here 3 is coming 4 times. So mode will be even be your 3. So your mean is coming 2.8, median is coming 3, mode is coming 3. All are very close to each other. So this is how we can find your mean, median and mode for any given observations. Now let's see question number 3. The following observations have been arranged in ascending order. Already arranged in ascending order. If the median of the given data is 63, median is given to us as 63. Find the value of x. See over here, number of observations is 29, 32, 48, 50, x plus 2, 72, 78, 84 and 95. So we will be counting the number of observation 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number of observation is your 10. So for finding mean, it is already arranged in the ascending order. So what we need to do is, because it is number of observation is even, so we'll be finding n upon 2th, that means 5th observation, and n upon 2 plus 1, that means 6th observation. So we'll be finding average of 5th and 6th observation. So what will be the 5th observation? 1, 2, 3, 4, 5. 5th observation is your x and 6th observation is your x plus 2. X plus 2. This is your 5th observation. This is your 6th observation. So average of these two will be the median, and median is equivalent to your 63. It is given to us. So what we will be doing is solving it over here. Average of these two, that is x plus 2 divided by 2. Sum of both of them divided by 2 will be the average of these two numbers. It is equivalent to your 63 median given to us. So x plus x will become 2x plus 2. 2 multiplied by 63. 2 3s are 6. 6 126 it will be. So 2x will be 126 minus 2. That will be your 124. Or we can say value of x will be 124 divided by 2. That is your 62. Value of x will be your 62 will be the value of x. So this is how, by whatsoever the information is given to us, we can find the values. This is all about your statistics chapter. Hope it is clear to you how to collect the data, how to represent the data in the table form, in the graphical form, and how to find the central tendency using mean, median, and mode. Soon we'll be coming with the last chapter, your probability of your class 9th maths curriculum. Thank you.